Okay, let's give you guys some more practice. So determine if this alternating series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, there's a theorem that says that if you look at the absolute version, of the sequence, if the absolute version converges, then the original series will also converge. So rather than looking at this, we are going to look at the absolute version of this. So the absolute version will equal this thing here. So it's really us discarding this. So if this thing here converges, so remember, if the absolute version, which is the case here, because the absolute version is this thing here. But if the absolute version converges, then the original must also converge. So rather than looking at this, we are going to look at this. So looking at this, well, n factorial means n times n minus 1 times n minus 2 times n minus 3 and so on until you get 2 times 1. And then n to the power of n means n times n times n times n. So this thing here is exactly the same as this. Now, if you look at this, hang on, here you put one block, here you put one block, and so on. If you look at this here, n over n is 1. This block here is the number 1. This block here is going to be less than 1. I don't know, maybe, let's just make it up, maybe 9 point, let's just imagine it to be less than 1. This one here is even going to be smaller. So let's say, I'm just going to make this up, let's say this. And then this one's even smaller. I don't know what it is, I'm just going to make it up. It's going to be a number that's less than 1. So now if you look at this, let's multiply these two together. So that would be 2 over n squared. So now you've got 2 over n squared times a number that's going to be less than 1 times a number that's going to be less than 1. Now if you have a number, let's say 80, and then you times a number that's less than 1, let's just say this, then this answer here would be smaller than this answer here. So if you look at this, hang on, so this is like one block. You're going to times a number. But don't forget, when you times this, it's going to be 1. The first block will be 1. So we can ignore that. If you times this one here, it's going to be less than 1. Times this one again, it's going to be less than 1. It's going to get smaller and smaller as you multiply each one. Because this block here is less than 1. This block here is less than 1. This block here is less than 1. So if you start out with this block, and then you times a number that's less than 1, it's going to get smaller. Times a number that's less than 1 again, it's going to get even smaller. It's going to get smaller and smaller and smaller. So let's just merge these two together. That will then give us this. Now each time you multiply by each of these blocks here, it's going to get smaller and smaller and smaller. So you can actually say this thing here will always be bigger or equal to this whole thing here. Okay, and don't forget you need a minimum of 3 blocks. Here you've got 1 block, 2 blocks. The minimum you will need is 3 blocks. So start out at 3. So remember, if you're trying to determine whether a sequence, whether a series will converge from 1 to infinity, you can just truncate it anywhere. You can truncate it at 3. If from 3 onwards it converges, therefore from 1 onwards it will also converge. So you can actually say that, well, merging these two together will give you this. Now, every time you multiply by a number that's smaller than 1, it's going to get smaller and smaller and smaller. So you can say that this thing here will always be bigger or equal to this whole thing here, which is this thing here. So, hang on. So, we can actually say that from 3 to infinity, this thing will always be bigger or equal to this thing here. So now we can tell that this thing's going to converge. Therefore, this thing will converge. So let's start again. Let's start again. Originally, we were trying to determine if this alternating series will converge or if it will diverge. And then there's a theorem that says that if you look at the absolute version If the absolute version converge, then the original version will converge. While looking at the absolute version, that's this thing here, well, the absolute version here will converge. Therefore, the original must also converge. So therefore, this alternating series will converge. Okay?